Xerox part.
Yeah, I know who he was.
Okay.
Okay. Well, I can try something, and then if it doesn't work, we'll try something else.
Okay.
Okay.
I'm actually rolling now.
Oh, you're rolling
I
now.
just pressed because we have so much tape. So
Okay. So,
I'll double check that I'm rolling. Yep, rolling and everything's happy.
okay. So maybe this is a chance to talk about an aspect of this that Doug rarely goes into, actually, but it has a tremendous amount to do with the bootstrapping idea, theme, philosophy, something like that. And that is that when we built the systems back in 66 through 72 or so, and then the work that Doug carried on, but primarily in that period, we were bootstrapping at every possible level. And one of the things we did back then, which was extremely novel, was that we built all our own software using our own software tools, which is something that Doug rarely actually goes into in depth. Probably pretty confusing for people, but we built a programming system. We actually called them the meta compilers, and they were compiler and programming tool systems that were written in their own languages that allowed us to then extend them and build on the bootstrapping concept. And this was extremely novel back then. There was a little tiny bit of work that was going on at System Development Corporation at the same time on this as a research topic, and that was all that we could find in the world. And we really took it to an entirely new level where the whole system was in fact written in its own language, and then allowed us to apply this bootstrapping technique of if we wanted to improve it, we could improve it by using itself to improve it and get the leverage out of it that way. This has since turned into a lot of research topics in a vast area, and today you even see work still going on writing Java compilers in Java and building the programming tool systems using their own tools, and all of this has its roots back into Doug's group. There's a different idea.
That's really good. He's talked to me quite a lot about this, actually.
Okay.
He thinks it's crucial.
Well, it is crucial, but it confuses most people enormously.
Yeah, it does. I'm glad Fleur's not here for this because she would really dig into that one because she's learning that part of it, but it's not relevant.
I'm trying to think of an analogy, and suppose that you wanted to push atoms around on a metal surface. That is, you wanted to do tooling so fine that you could move atoms. Well, what do? You start building very, very high precision tools, use those tools to build higher precision tools, and you just continue this process, and if you work hard at it for 40 or 50 years, you've got the Santa Teresa lab pushing atoms around. That's okay. So that's the theme. It's tools to build better tools.
Okay, yeah, that's good. Why don't you just talk about actually getting around to, you see, the thing is, when I talk to my friends about this, one of the things to talk about is the verbs and the nouns, and they freak out. They get really upset at what we have today compared to what you guys did, right? And then they always have this vague notion that it never really happened. If you can just say, yeah, we actually, how the hell did you make it happen? This abstract thing into a real tool set.
How did we make it happen?
Yeah.
The amazing thing was there were a very small number of us. I don't remember exactly how many, but working on this 68 demo, there weren't more than a half a dozen or so people doing software engineering. With extremely high productivity. And I remember we built prototype systems on the CDC, boy, I'm losing track, 31 or 3300. And we had bits and pieces running, but nowhere close to an integrated system. When we built the 940 system, we took a big conference room inside SRI. It was an interior conference room. We had them line the walls with brown blackboards. We set up a bunch of tables in the middle of the room. We didn't have the display system running yet, so we had model 33 teletypes that we programmed on, and we filled the boards with graphical representations of the data structures of the entire system, and we sat in the room until we had it programmed.
How did you
We closed down the Oasis in Menlo Park many, many nights, let me tell you.
That's amazing. This thing, though, I don't understand. The verbs and the nouns, right? You have to come up with a way so that, if I understand Doug correctly, that anybody could write another verb, another tool, and that verb would then just kind of slot into everything else. How did you actually do that?
Well, I'm not sure. Yeah. Maybe the thing he's talking about there is that the entire, in this meta-compiler system that we built of the programming languages, we not only built it so that,
Some water or something?
no, it's okay, it'll go away. We not only built it so you could have a description of, so that you could write software, but there was a language. Oh, this is fun for the Java people. We designed a language that allowed us to describe the entire user interface in a programming language that was very, very similar to the programming language in which we wrote the programs that implemented the interface. And in this language, the way it grew up was I took all of Doug's ideas from the 3100 and I built a state diagram table on a big piece of paper.
What is 3100?
The control data, that was the preliminary machine.
That's just
Yeah, but I didn't even know that it's a computer.
Oh, it was
That's okay.
it's a control data machine that was the one we had before we had the 940,
Yeah.
which was another computer that was the one that was used in the big
I
demo.
think we need to either know or not know that, because what we're looking to,
Yeah.
when you talk about this, I'm okay, I'm editing this, Ahmed.
Okay, so
This section, okay?
so I built a state table, and then from that state table, I was actually able to design a rule-based programming system that could be compiled by the meta-compiler system we had built, which implemented the entire user interface. And that's how we got this thing going. Historically, this is rather interesting because that programming language, then the other people on the ARPANET at that time, namely Steve Crocker, I'd have to go look up the names. I can't remember them. No, he wasn't around yet.
Okay.
It was mostly Crocker, Vint a little bit, Surf, but not a lot. A couple guys from Utah saw this as really neat, and I turned it into a more formal definition called the encode-decode language. No, decode-encode language for decoding user interface stuff and decoding it as the user types it in. Anyway, I defined all this stuff and wrote it down, and it turned into RFC number 5, which is still on, you can get it in the RFC archives. And it had a lot of very fundamental ideas in it about how one represents user interfaces. It also implemented a notion of coroutines, which at the time is a precursor of object-oriented programming. And about 5 or 6 years ago, I was sitting in my office one day here at Sun, and the head lawyer for Sun, Jim Morris, came in and threw this thing down on my desk and said, "Did you write this?" I looked at it. I hadn't thought about it since 1970 or so. And it turns out that some people had sued Sun over the original concepts for Java and claimed they had a patent. And the Sun Patent Office went off and did a prior art search, and RFC 5 showed up as the prior art. Gosling never knew about it, but it showed up as the prior art.
That's pretty cool. Can you explain to Fleur what an RFC is?
Request for comments. This is a system that a process that the IETF, Internet Engineering Task Force, uses to document and go through the process of standardizing Internet protocols. And there are 2 or 3, I don't know how many thousand now, it might be up in the 4,000s. All the major Internet protocols are archived this way. RFC number 3 is one that I wrote that came out of Doug's group, which was a proposal about what the content of RFCs should be. Natural Engelbart stuff, right? If you're going to have RFCs, you have to have a definition in RFCs of what RFCs should be. And number 5 was the proposal for the user interface meta language.
The term RFC started because the guys who were doing the very, very beginning didn't think they were the ones doing it, so they requested a comment
Right.
saying this is the spec.
Right.
So it's a very, very social way of doing it. One thing that I think we
This was back when there were only 4 of us rather than
yeah,
the 10,000 that work on it now.
exactly. Maybe it would be really nice if you move up there and you tell Fleur while she's in the shot what it was actually like working with Doug, the dynamics of actually getting it done. Because that's going to be quite animated, I can imagine.
How can I do this? The dynamics of working with Doug. I have many stories. I'm not sure I should tell them.
We had on tape so many times saying that because of you, these things happen. You and Bill English come up again and again and again. He knows he was difficult. He knows all this stuff.
Okay, so I'll tell you a fun story.
Yeah.
Hang on, not yet. Because you're too far away. Can you get closer to her? She can't get closer to you, so.
Okay, so here's how it started. I was at the University of Washington, and I was a real hotshot system programmer there working on my undergraduate degree and employed full-time by the Computer Center. And they wanted a big, high-speed computer, and they sent me to the 1965 Fall Joint Computer Conference to talk with people about getting companies like Control Data and IBM to donate a computer. So I went. And I was wandering around the floor, and I found these strange guys with long hair and sandals working on this computer, Scientific Data System 930, building a time-sharing system. And it was Butler Lampson and Peter Deutsch and Mel Pertle and Doug Engelbart. I'm not sure if Bill English was there or not. I don't remember that. Anyway, these guys were great because I'd actually been studying some of their code from other things. But I didn't know about Doug. I met Doug. He explained to me the vision. I got it. He invited me to go back to SRI. This was in October. He invited me to go back to SRI. I called my wife and said, I'm not coming home. I'm going to Menlo Park, California. I went there for a week. And on, I think it was January 2nd, 1966, I started work in Doug's group. And I'd moved there. So I got the vision in the first hour of him explaining things to me.
Yeah.
So,
I need to move you. That was great, but now, can I just swirl you around, do you mind? Because we have too little of your head in it. So
Okay.
Yeah. Could you say again, I met Doug, I got his vision in
No, that was great. It looked
Okay.
great, but
Did
for,
you get it
for
right?
anything else.
okay.
Because,
Okay.
pretend you guys have a piece of paper here and you're kind of talking over a piece of paper, just so your direction is a little bit towards
a
me.
little bit, yeah.
Okay, so I got it. I knew
Yeah.
exactly what he was going to do.
Yeah.
And I came down and I got myself into Stanford Graduate School. And so I was a graduate student and I worked on Doug's project.
Right.
And I would go and take classes and I was working a crazy amount of time.
Pause, please. Because you're already pausing this chair. But I want people to look at you guys and nothing else.
He had as part of a joint funding program, gotten a lot of access to this CDC 3100 at SRI, it's a control data machine. And on that, with the help of the guys at Project Genie at Berkeley, we actually built, I guess what you would call prototypes of the various facets of the system. So we had built the debuggers and the compilers in their own language in a much more primitive way, and we had actually done a lot of the experiments with the mouse. Bill English was running that. We had ergonomic experiments going on. And we had built a very simple version of the editing system. And we made films of that. And with that, we managed to convince ARPA, now called DARPA, but at that time ARPA, to get us a 940 and expand the project.
Pause, please. I have to move the
This
camera.
was really good.